Welcome to SCI-EASE. You know that light, it travels in the same path. But when light travels from one medium to another, still the light travels in a straight line? Or you can see that when you look at the pond or tank, that appears to be, its base appears to be slightly raised. In the same way, when you immerse pencil in the tumbler filled with water, it appears as if it is slightly broken. And also, when some coin that is placed in the bowl and you pour some water over it, the coin appears to be somewhat raised. In the same way, when we put lemon in a glass full of water, lemon appears to be very big from the side of the glass. So, what is the cause of all these things which we happen to see in our day-to-day life? So, first, I will show you the tumbler which has water in it. And I have immersed, this is a pencil and it is not a broken pencil, okay, or pen you can say. I put this pen in a tumbler filled with water. When you see, you will see that this pen is broken at this point. But when I will again take it out, it is a single piece. So what happens at this interface? What happens at the interface of water and air? जहाँ पे ये ग्लास खाली है वहाँ air है and here there is water. What happens at that place? When we see the part of the pencil which is immersed in water, the rays, they will enter from different direction to our eyes. And when we see this upper part which is not immersed in water, the rays, they will enter from some other direction. So, when there is bending of light, this means there is bending of light. When the light rays travel from one medium to another, this is known as refraction. First we have done reflection. In reflection, we strike a ball on the wall. It will come back. Okay? But here we have seen that when light travels from one medium, that is from air to water, it will change its direction. Okay, it will change its direction, or the light bends, you can say, and this bending of light, that is known as refraction of light. So my topic is refraction of light. I will perform another activity. Here I have bowl in which I have put this coin. Okay. Now I will stand at that point where I cannot see the coin. Now I will pour some water in it. Here it was. Earlier here it was. I will pour this water to it. Then from the same point, coin appears to me. Okay, coin appears. It seems as if coin is raised, थोड़ा ऊपर हो गया है. जिस तरह से मैंने आपको क्या बताया कि टैंक देखें या पॉन्ड देखें जिसमें पानी है तो वो हमें उसका बेस स्लाइटली रेज्ड लगता है. In the same way, now coin is visible to me. I have not changed the position of the coin, and I am standing at the same point where initially coin was not visible to me, but now the coin is visible. It appears somewhat raised. This is again due to the refraction. So what refraction is? Refraction is the bending of light when it travels from one medium to another. What do you mean by this medium? Air is a medium, glass is a medium, here water is a medium. Okay, so when light travels from air to water, there is bending of light. In the same way, when light travels from air to glass, then also the bending of light that will take place. One thing I want to tell you here, that if I take turpentine oil instead of water, then tell me the same bending will take place or some different bending, much more or lesser than the previous one, initial one. That will be changed. Okay, so it depends upon the medium through which the light is passing, from air to turpentine oil or from air to glass. That is different. You know that the speed of the light in air, it is 3 into 10 to the power 8 meters per second. So it is the speed of the light in air. It will be different in glass, lesser, because water is denser than, now the two terms, denser and rarer. Okay, air is rarer medium, water and glass, they are denser than air. I will use these words here. The velocity that will decrease, velocity of the light that will decrease in water and this glass. So my topic in this video, that is refraction of light, and I have told you so many examples which we come across in our day-to-day life. Now we perform one experiment of this chapter, refraction of light, that I am going to tell you that when the light travels from air to the glass slab, then what happens? I want to tell you here that there is a short in my YouTube channel where the refraction of light that is told, where you can see that how the refraction of light that takes place, that I will show you. Okay, and then I will do this refraction through a glass slab. In this video, we will perform water refraction experiment. We will take a sheet of paper and mark arrows on it. Now place it behind the empty glass and add water to it. As we add water, we see that the direction of the arrows get reversed. The phenomena leading to this change is called refraction. So when light passes from one material to another, it bends or refracts. Thus, in this case, glass of water acts as a magnifying glass, and when light goes through a magnifying glass, the light bends towards center, which is the focal point beyond which the light rays pass in the opposite direction, thus reversing the image. Now next is refraction through a glass slab. Here there are two laws of refraction which we will deduce just now. We take a glass slab, okay, take a glass slab and take cardboard and one plain sheet of bigger size, okay, and place this glass slab over the paper, white paper. पिन कर दो सब तरफ से, कार्डबोर्ड पे हमने पेपर लगा दिया, उसके ऊपर ग्लास स्लैब रख दी, ओके, एंड ग्लास स्लैब की वी विल ड्रॉ अ बाउंड्री, ओके. नाउ यू प्लेस टू पिन्स, एक लाइन हमने खींची, ओके, वी विल ड्रॉ अ लाइन here. We will place two pins on this line, okay, or you just place two pins in line, okay. Now see from this side so that and place two pins on this side so that they are in one line, okay, and then you will remove the glass slab and draw normal. What you will do, that you will draw normal. What do you mean by normal? It is 90-degree angle, okay. This is the incident ray. Suppose this is the incident ray. Angle formed by the incident ray and the normal, that is angle I. Now what will happen? This is the rarer medium. It is a rarer medium and glass is denser medium, okay. Now when light travels from rarer to denser medium, must listen it and remember these two lines, that when light travels from rarer to denser medium, it will bend towards the normal, okay. It will bend towards, थोड़ा normal की तरफ ये होगा, and this will be, this is angle I1 and this is angle R1, angle of refraction, okay. Now this ray will become incident and it will strike at the second face of the glass slab, okay. Now again draw a normal. Again draw a normal, 90-degree. Now this is angle I2. This is angle I2. Now what happens to this ray? Now the ray is moving from denser to rarer. This is again rarer medium. This is again rarer medium. So what will happen? What will happen? The ray will bend away from the normal, okay. Then ray will bend away from the normal and this ray will emerge out. This ray will emerge out. So here you will see that this angle, that is equivalent to this angle. So this is R2. Clear to all of you? I'll again repeat. The ray will start from here. It will incident on this here, AB face of the glass slab. Because the ray is traveling from rarer to denser medium, it will bend towards the normal. Okay, when ray travels from rarer to denser, it will bend towards the normal. Now it will strike this face, okay, CD, and this ray will become now incident ray, and now the ray, it passes from denser to rarer, so it will bend away from the normal, okay, it will bend away from the normal, and this will, you will see that these are parallel, and when you will extend it, what you will see, that this is the displacement. How much is the displacement? This. This much is the displacement, you will see. Okay, so this practically also you will perform during your practicals. Okay, and then the things will become more clear. Still, I have told you each and every point that how this ray travels from rarer to denser and from denser to rarer. So what you will note, when ray travels from R for rarer, rarer to denser, D for denser, it will bend towards the normal, towards the normal. And second thing, when ray travels from denser to rarer, it will bend away from the normal. So, like laws of reflection, we also have laws of refraction. So, there are two laws of refraction: the incident ray, the refracted ray, and normal to the interface of the two transparent media. Like in the case of, I have told you how this pencil that is dipped in water. So the interface is air and water. Okay, so the incident ray, the refracted ray, and the normal to the interface of the two transparent media at the point of incidence, they all lie in a same plane. Okay, this is the first law. Now second law is that reciprocal of sine I. What is I? This is angle of incidence. Reciprocal of sine I to the sine R is always constant for one color of the light and for the two definite media. Okay, this thing should be clear to all of you, that sine I to sine R is constant for the same color of the light, okay, and for the two media. Clear? Now this expression, it is known as Snell's law. It is known as Snell's law. So I have told you in detail about the refraction. By taking some example, you can also perform these activities at your home, like pencil or pen dipped in water, वो कुछ टूटती नहीं है. In the same way, coin that is put in the bowl full of water, and then I have one shot that also you can perform on your own, and then putting lemon in tumbler or glass full of water, you will see that its size increases. This is all due to the refraction of light. So I think the term refraction, that is clear to all of you, the bending of the light when it passes from one medium to another. So I will meet you in the next video, and I will discuss refractive index. This term is again new for you, refractive index. Till then, thank you very much.